Hello, student. Dear student, we start today the first chapter, solid state, and some basic information of solid, especially the first slide, matter. So, according to the definition of matter, matter is anything that has mass and take up space or has volume, or if any types of things they identify in our five sense. So, it's also called a matter, and physically they are divided in solid, liquid, and gas. So, according to the definition of solid, the particles can closely pack, and liquid, the particles can some fur comparing to solid, and gas more fur. So, this is the region. The solid particles, the intermolecular force is strong comparing to liquid and gases because the particles can closely pack each other. And liquid, the intermolecular force is weak comparing to solid but strong to gases, and gas, the particles more fast, so the intermolecular force is very weak. So this is the part of solid, liquid, and gas. So, and also the properties, and just see here the intermolecular structure of a solid. Here two types of balls, color blue and green. It means there are two types of charges, and if we see, they are closely packed to each other, every portion. So this is the region. The shape size are fixed, and also the next slide, character or properties. So what are solid or characteristics of solid? They have definite mass, volume, and shape because the intermolecular force or the particles can closely pack. So intermolecular force are very strong. So intermolecular distance are very short, and intermolecular force are strong. And their constituent particles like atom, molecules, or ions have fixed position. Means the position are fixed, even any atom or molecules or ions, and can only oscillate about their main position. And number fifth point, they are incompressible and rigid. Means when the particles can closely pack, so they are incompressible and rigid also. And there are two types, means the solid the types of, there are two types, crystalline and non-crystalline, means amorphous. And the difference, crystalline substance and amorphous substance, definite characteristic or geometrical shape, and non-crystal irregular shape. Means in crystalline the edge, vertex, corner, everything are definite, but in non-crystal irregular. And crystalline substance melt at sharp and characteristic temperature, means in a particular temperature they melt. And non-crystal gradually soften over a range of temperature. Crystalline, when cut with a sharp edge tool, they split into two pieces. That means when we cut a sharp any types of tools, they split into two pieces, and they newly generate surface are plain and smooth. Means again these types of pieces are changed in the form of two types of surface area. Okay. And non-crystal, when cut a sharp tools, edge tools, they cut into two pieces with irregular shape. Means the original substance in irregular shape, and also when the subtracts or cut to any types of tools, the new types of parts form new types of parts also irregular shape. Next point, they have a definite and characteristics enthalpy of fusion. And non-crystal means they do not have definite enthalpy of fusion. And anisotropic nature, true solid, long range order. And in amorphous, isotropic, pseudo solids are super cool liquid and only short range order. So this is the difference between C, CS and non-CS, means crystalline and non-crystalline. This is the crystalline structure. Here, if you see, the particles can closely pack to each other. So this is the region, surface, edge, corner, vertex, everything are clear. But amorphous solids, the particles can chamfer like that, here or here or here, here. So this is the region. The shape of crystalline is fixed and here not fixed. And this is the example. Here crystalline means quartz SiO2 silicon oxide, and this is the glass, same SiO2, means in red color silicon and blue color is oxygen. So this is the structure, and these types of crystalline, the shape size are fixed and here are not fixed. Okay. And dear student, the next video we discuss isotropic and anisotropic nature. Okay. Thank you.